Good afternoon. We're at the Jacob Edwards Library in Southbridge, Massachusetts, and we have a presentation this afternoon from Dino Tata called Asteroid Impact, the Defense of Earth.
Okay, thank you, Margaret. Well, thank you folks for coming. Glad to see you. I'm Dino Tata, NASA Solar System Ambassador, and my job is to do what you're going to see today, to get NASA's word out to the public, let you know what their missions is, what they're doing, and try to increase interest in space travel, and science. And today we're going to talk about the defense of planet Earth. Basically, what do we do if there's an asteroid strike? Fact of the matter is there's hundreds of strikes every single day, but they're like the size of a grain of sand. So it's that little flash you see at midnight going across the sky. We sometimes call them shooting stars, and they never do a lick of damage. So what is an asteroid? Well, there are a number of types. It's a rocky mass that we're going to be talking about today, and it revolves around the sun. Usually comes from a place called the asteroid belt. And it's all different sizes and shapes, and they can crash into Earth as we know, but normally they don't. The atmosphere burns up most of them. The larger ones, that Jupiter's gravity usually pulls out of the sky and takes it in itself. And the rocky mass is a solid asteroid. We also have some we call a rumble pile, which means a bunch of little pieces formed together, but they didn't hit each other hard enough to meld, so they're still loose. And there's a few other types as well. So where do they come from? The asteroid belt. Now the asteroid belt runs between the planet Mars and the planet Jupiter. And actually we have Mars here, we have Jupiter here, and this is the asteroid belt. Now there are a few 100,000 asteroids in there, ranging from a pebble size to the size of a house. And as well as that, we have what we call the Trojan asteroids. You have the planet Jupiter here. These are the Trojans, and those are the Trojans. They both travel the same orbit as Jupiter, and they both travel at the same speed as Jupiter. So there's no collisions. But what happens every now and then is if Jupiter's orbit takes it too close to this, it'll pull some out of there, and usually some will go flying in towards the sun, because the sun has the greatest force of gravity out there. So it's thought to have, the asteroid belt is thought to have formed from leftover debris during the formation of the solar system. We started as a great solar disk of dust, ice, and gases. Looked like a huge pancake out there. And eventually the pieces, because of gravity, were drawn together. The bigger it got, the more the gravity built up, and the more it attracted others. And finally, the one right in the middle, when it got big enough mass, it ignited. That became the sun. The rest of the sun took up like 95% of all the debris in the disk. And then after that, the planets formed in the same fashion. And originally, there might possibly have been up to 100 planets. But as the solar system was still forming, they collided with each other. So we're down to the 8 or 9 planets we now have, plus the asteroid belt. A number of theories exist about what caused this asteroid belt. The one most favored is that the asteroids would have clumped together into another terrestrial planet, but Jupiter was so close, its gravity kept tearing it apart, preventing them from clumping together. At that, the mass of all the asteroids ever combined would only be 4% of the mass of the Moon. So it wouldn't have been a very big planet at all. So how do we find them? Well, NASA does surveys based by Earth-based telescopes to look for these things. We have the Catalina Sky Survey, which is a grouping, and then space-based telescopes as well. And they have identified hundreds of asteroids while scanning the sky at near-infrared wavelengths. Space-based telescopes have identified hundreds of the asteroids. And this is the Surveyor spacecraft. That's supposed to fly in 2027, I think. And it's designed specifically to find NEOs, which we call near-Earth objects. That's a near-Earth object is a body with an orbit within 120 million miles of the sun. So we're 93 million miles away. So these things that they were looking at, the big ones, they're like 27 million miles further away from the sun than we are. but that's close enough to us. In terms of how vast space is, with the distance is so great, we don't say miles, we say that's how far light travels in a year. And light travels at 186,000 miles per second. That means you could fly around the world 7 times in 1 second. So even at that speed, it could take 100,000 or 1,000,000 years to get there. Vera C. Rubin Observatory is in Chile on a mountaintop, one of the most powerful telescopes ever built to survey the universe. I call it a camera telescope. It has a camera built in, and this thing has millions of pixels. So it's compared to my Canon with its 6 pixels, right? It's a fantastic telescope. It was supposed to go online in February. It has not gone on yet because they still got some adjusting to do. But finding the near-Earth objects is just one of its capabilities, but it will do a lot of that. You can compare this to the James Webb telescope. It's so powerful. And these are some of the spaceships we have out there to check out. We have the OSIRIS-REx, Psyche, Hera, and Lucy. And these are out there looking for asteroids and things that are on the way to Earth that might collide with us. So how do we know it's an asteroid? Well, this picture you see is March 8th, 9th, and 10th. It's the same field of view, except as you go across, on March 8th, the dot was here, 9th, 10th. The stars, in spite of the fact that they're moving at thousands of miles an hour, are pretty much steady in appearance. They're so far away, they can move 1,000,000 miles and we won't even see it. But the asteroids and the planets, they're what we can call wanderers, they move. So we take a picture like this 3 days apart, and we see that object has moved. So we know it's not a star. It's either a planet or an asteroid. And if it's a planet, we'll know about it. So we know these are asteroids. So we compare multiple images several days apart, the same region of the sky. You can do it like an old flip movies. You can flip it, you see the movement go boom, 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 boom. And it's the only thing doing it, so that's what it is. And stars, as I said, are in the fixed position relative to the other stars around them. And a near-Earth object is going to be in a different position every day, and we can find it, provided it's bright enough. There are 730,000 known asteroids, and about 16,000 of them are near-Earth objects. Currently, we know about just under 1,800 asteroids that are potentially hazardous to Earth. And we have agents dedicated to tracking these asteroids, so we know where they are, if they're endangering us. And the Center for Near-Earth Object Studies, our Planetary Defense Coordination Office. These agencies analyze the asteroid impact and how it would be over the next 100 years. So are they a threat to us? Well, here's what can happen. This is the Alvarez impact theory. If an asteroid is 4 to 9 miles in diameter hit the Earth today, it would cause huge fires throughout the entire world. It would increase the activity in already active volcanoes. You have a lot more eruptions, a lot more sulfur gas in the atmosphere. If it, seafood vibrations would trigger huge tsunamis, and intense storms and high winds would result. And a lot of these don't hit the Earth directly, about a few miles above the Earth, they explode, and so it spreads the disaster even further than the direct hit. And that would create a lot of winds. Chemicals in water in the air would mix and would bring back acid rain. So how often do they hit Earth? Well, this picture depicts Alabama on November 12, 1833. You've heard of meteor showers when you might get 100 meters an hour. This is what we call a meteor storm. This can bring in like 100,000 an hour. It happened in Alabama, and in 1833 we didn't know a lot about astronomy and science. Caused a panic. People thought Armageddon had come. Some people thought the rapture had hit. And a lot of people thought we're all going to die. This is the end of the world. Well, a lot of these things were just the size of a pea or something burning up. It lasted most of the night and into the morning. And the reason we have Frankie's picture up there, you might remember he made a hit song called "The Night the Stars Fell in Alabama." So I put him up there so you can get. Now, it was made such an impression on the people that for 50, 60 years after that, people still referred to it to specify a date. Like you may say, when did we have our first kid? And you would say, about a year after the night the stars fell. Okay, when did John graduate from college? Oh, that's 10 years after the night the stars fell. So it became a reference point for people in Alabama. So this happens in the constellation Leos. It's officially known as the Leonids, and it still happens today, though not as dramatically. They originate from the Tempel-Tuttle comet. It has an orbital period of 33 years. It puts on a spectacular show and dates back to 900 AD. And the Leonids we can still see today. And it's almost the cycle of this for 33 years. It's pretty accurate. It's only missed the 33 years once that we know of. The fragments are pieces of rock and ice broken from the main comet as it evaporates from the warmth of the sun. And it reflects a huge number, as I mentioned, about 150,000 meteors per hour. The most I ever saw was in a 2-hour period. I saw 400 once, right up on Dresser Hill, but it was nothing compared to what this was. So we have Abraham Lincoln here and Frederick Douglass, because they did surveys of the public in 1830. What did you see? What did you think? How many were there? Just to make a historical document. And they included a lot of people. Some of the accounts were various Native American Indians, Abraham Lincoln, Joseph Smith, and Frederick Douglass all contributed to the study. So how often do we hit? And every dot, red dot, is an impact. Everywhere we see a red dot, an impact landed on the Earth. And this does not include the water strikes. So there's even more than what you see here. But you notice Russia has quite a few, and there's a reason for that. Russia is one of the biggest land masses in the world. So it's a big target. And this is the North American, the black dot impacts. And down here at the very bottom, where I got Yucatan Peninsula in Mexico, you see the dinosaur killer. That's where the one that killed the dinosaurs 65 million years ago landed, in the Yucatan Peninsula, right off the Gulf of Mexico. And so when was the last time a killer asteroid hit the Earth? Well, that was it. 65 million years ago at Chicxulub. And it was a catastrophe for life on Earth. We were very lucky that man wasn't walking the Earth at that time. It created a crater 93 miles in diameter. Now that's the distance from Boston to Amherst. And as you can see, half of it's on the land and half of it's in the Gulf of Mexico. So this not only did a lot of damage on the Earth, but also caused huge tsunamis. And the crater is 12 miles deep. And they didn't even know, mankind didn't know that crater was there until we could fly. From the sky you could look down and they said, gee, there's a semicircle there on the Earth. And when the divers went down, they found the rest of it. 70% of life on Earth was destroyed. And that allowed, the dinosaurs were here at that time, that allowed the mankind to arise and evolve. Now, every now and someone says, did we walk the Earth at the same time as the dinosaurs? No, we're separated by millions of years. If we walked the Earth at the same time as the dinosaurs, they wouldn't have called us mankind. They would have called us lunch. So the asteroid was twice as big as Mount Everest. That's what it takes. Came in at 31,000 miles an hour, and the debris it created, the smoke rising from the fires all over the world, caused a decade-long winter because it was so foggy it just blotted out the sun. It released 40 billion times the energy of the Hiroshima atomic bomb. The tsunami created was a mile high, and it created a wall of fire across the continents. The reason it causes the wall of fire is it throws debris up past 70, 80 miles up, and then it comes back down, hits the atmosphere, and gets the friction, starts it on fire. So you get thousands of little pebbles coming down on fire. Some of them hit the earth. Some of them are big enough to hit the earth. What kind of damage can you do? Well, if you figure that you had one that's, say, 1,000 times the power of Hiroshima, coming in at 43,000 miles an hour, if it landed in the middle of Central Park in New York City, the first 9-mile radius or an 18-mile diameter, nothing would survive. Nothing at all. Take an 18 mile circuit, you see that. This one here would have exploded 9 miles above, so what we call an air burst. So it's serious damage. Can it happen again? Well, it already has. This is the alien asteroid strike. Happened on February 12th, 1947 at 10:38 a.m. Happened right here, you see where it says VUS. Happened right in that area. That body of water is the Sea of Japan. Now, what you have to know about this is that the timing on this one was terrible. Sikhote Mountains is a number of ranges of mountains. When this exploded, the boom was heard miles away. And the boom bounced from mountain to mountain. So the public, there were none in this area, but miles away they could hear it was going boom, 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 boom. This happened after a big event at that time. It's 1940. Do you remember what event it was?
The war.
Yeah, World War II. Yeah, World War II. A lot of the Russian people thought the Americans were putting on a sneak attack. There was one politician who swore that an American politician met with the Russian politicians and planned this. And of course, we don't direct asteroids, do we? But luckily, cooler heads prevailed. No one started a war. But they really thought the war was on again. This thing weighed 25 tons and came in at 31,000 miles an hour. One of its craters was 85 feet across and 20 feet deep. It had a number of craters because it was an air burst, you know, and a number of big chunks fell off. The flash and sound were seen and heard 100 to 90 miles an hour, and the smoke trail was 20 miles long and lasted for hours. Can you catch?
Once in a while.
Catch. Oh, you missed
It
it.
was a bad pass.
Oh, yes.
That is a piece of this asteroid. Okay. Now you notice when you hold it, it's heavy for its size. That's because there's 95% iron. The last 5% is made up of 22 elements: copper, gold, silver, uranium, water, a whole bunch of things. And you see, this here is one of the pieces embedded in the tree. You can judge your size by seeing the sledgehammer there.
Can I just...
And this is a larger piece. This piece weighed 3,800 pounds. Took a truck to pull it out. Now the thing crashed in the middle of the woods, so in the wintertime, so they had a hard time getting to it. Russia issued a memorial stamp on November 20th, 1957. And it, 40 kopecks. And this is not a picture, this is the actual stamp.
You went to Russia to get it?
Yes. I had to sneak it out in my coat. And this is before and after the Sikhote Mountain. So there's a well forest there, the area they call the Tiagra. And this is what it looked like after the explosion.
I'm kind of intrigued, you know, how we get to know, you know, what speed they were coming in, what mass they were, what diameter they were. Because, I mean, nobody was up there with a tape measure.
No, but this one, thank you. Yeah. This one was an observed burst. Mm-hmm. In the morning, people were up and around, and they saw it coming in, so they could calculate direction, speed, things like that. In fact, that stamp was painted by a guy named Medvedev. I can never pronounce his Russian name, but he was an artist, and he was in his kitchen, and he saw it coming over, and he painted this picture right after it was done. And so they made a stamp out of his picture. The story is, though, the only problem is, he has that smoke trail. It says it came from the other direction. Then we had the Tunguska impact. This was June 30th, 1908 at 7:17 in the morning. And you can see the red spot, the Tunguska event, once again in Russia. Now these things, like Sikhote, Alien, and Tunguska, If they happened in a population area, it would have been disastrous for that area. You know, it's happened in a middle place like a city like New York City, you would have hundreds of thousands dead. This one weighed between 3 and 50 megatons. So you see clouds, they're not exactly sure. They got a wide range. Huh? 160 to 200 feet in diameter. It toppled 80 million trees over 830 square miles. And there's, you can see a picture of the trees that were toppled. Then we have what we call dark asteroids hidden. And this type of asteroid, I call it dark because we can't see it. We don't know what's coming in because it's coming in from the direction of the sun. And you can't really look at the sun and see. You certainly can't turn your telescope on it. So you can't see it. But this was the Chelyabinsk media. This was another one in Russia. Like I said, Russia's a big target. Well, can it happen here? I'm sorry, the Chelyabinsk one, that happened during the day, and a lot of people were injured.
When was this one? Is this a 1908 one?
No, this happened maybe, 10 years ago, maybe 15 years ago? Yeah. It landed it did in a populated area, but 1,500 people were injured. And the reason they were injured,
They looked up?
no, close though, but it blew up like that above the air. It was an airburst. But so people heard the boom and they saw a flash of light. So they all ran to the office window or the house window to see what the heck was that, right? You ever see a picture of an atomic explosion? You hear the boom, you see the light, and then there's whoosh, a big force of air blown out. That happens at this too. So that force of air came out and blew out the windows, and most of those injuries were glass injuries. People got there, and it did shake up some buildings. They had I believe it was a lead factory that it knocked one of the whole walls down on the factory. And a lot of the pictures we see, like this is an actual picture of it. This is not a drawing. You're seeing the actual media that came in. And in Russia, a lot of people have dash cams on their cars because they want to be protected in the event of an accident. They want to be able to say it was the other guy's fault. So a lot of the pictures we have of this came from dash cams. So it happened here 50,000 years ago. This is Meteor Crater. It's located in northern Arizona. It's now a tourist attraction, also known as the Barringer Crater. The reason for that is they thought this was a big iron meteorite weighing tons, and they thought, oh, it must be buried in here. So the Barringer family bought it, thinking they could mine all the iron. Well, they just mined it, but they never found the meteor. So this crater is 4,200 feet wide, 650 feet deep, and it was a 300,000 ton impact that it hit. That came in at 29,000 miles an hour. And Klaus, I think so as they look at the crater and how big one does it take to make that, how fast does it have to hit. So we get these speeds like 29,000 miles an hour. It's their best estimate, really. So can it happen again? Well, here are some that are coming our way. These four are heading past Earth at up to 50,000 miles an hour. That first one is the 2020 KK7. That's coming within 310,000 miles. Now that's the other side of the moon. Sounds like a great big distance, but in space, it's your next door neighbor. That kind of a distance. The next one is coming in at sorry. Is 144 foot, is 2.9 million miles away. And then 2000 KF, that's 1.3 million miles away. And the last one is 2.5 million miles away. Headed this way. None of these are expected to impact the Earth, by the way. And these are three that we think could. And for size, we put the Empire State Building on the left. So that Bennu, that is going to come in 2880, so you don't have to worry about that one. None of us do. And I'm sorry, Bennu is the middle one. That's going to come in on September 28th, 2182. And the Apophis is coming on April 13th in 2029. So see that big one, that's a real beaut. This is the one that's making all the news right now. Asteroid YR4. This is going to make a near-Earth pass on December 22nd, 2032. So that's 7 years from now. It's got quite a long orbit, and it's got good size to it. When we first saw it, we were concerned that it might impact Earth, because it's going to be a close one. It was discovered in December of last year. This is what it looks like today. That little spot in the middle. And it's a stony type asteroid. We also call it an Apollo asteroid, because that means it's an Apollo asteroid when it crosses Earth's orbit. So as it goes by, it's going to cross Earth's orbit. We just have to try not to be at the spot where it crosses when it does. So it orbits the sun every 4 years, traveling about 33,000 miles per hour. Now, we're not like that. We can calculate their speed by seeing where were they today, where are they next week, where are they the week after. And we know what that distance is, so we can figure it out. Between 130 and 330 feet long. When we discovered it, it was moving away from the sun. So it's gone its way out. But it's going to, at the end of its orbit, it's going to swing around and come on back towards Earth. So what would happen if it impacted Earth? Well, it impacted the Earth with a force equal to 8 million tons of TNT. It'd be 500 times more powerful than the Hiroshima atomic bomb. A land impact would cover up to 30 miles from the impact. An ocean impact would cause devastating tsunamis. If it occurred, this is the most likely path. Going to come into the atmosphere over the eastern Pacific Ocean, go over northern South America, over the Atlantic Ocean, over Africa, the Arabian Sea, and then finally over to South Asia. But don't panic. We have determined now that this will not strike the Earth. Now, you can't guarantee that, because as it travels through space, it runs into gravitational forces of other planets. It may even collide with an asteroid that alters its course. So, but our calculation at this time showed that it's going to miss Earth. So how do we protect ourselves? Well, there are 5 ways we can do it. We'd have a nearby nuclear explosion. We can use laser sublimation, electric propulsion, a gravity tractor, or the solar sails. So first up, nuclear blast deflection. We exploited an atomic bomb near the asteroid to alter its course, or in front of it to slow it down. If you slow it down, you change its course. And so the obvious question is, why don't we just blow it up? Well, can't do that. You see the first frame, the red line, that's a rocket going up to blow it up. The second frame, it hits it, it blows it up. The third frame is all the little pieces of what you blew up. They're all in the atmosphere, they're all on fire, and they're all falling to Earth. You'll have, instead of having one giant coming at Earth, you'd have a couple of thousand flaming arrows coming down, setting the world on fire. So you can't do that at all. All you can do is blow up near it and try to alter its course or change its velocity. Now, laser sublimation, if you take an ice cube and you melt it, ice cube is solid, you melt it, it becomes a liquid. If you leave it there long enough, it's going to evaporate into a gas. Sublimation is when you go from a solid to a gas without going through the liquid stage. And that's what this system does. By firing a high-intensity laser at the surface of the asteroid, the energy starts to vaporize the material. And that causes like an ejector, like a little jet. And like with a rocket engine, the gas material is used to deflect the path of it. Now, if it's far enough away, we only need to deflect the asteroid path by 1/10 of 1%. But deflecting any of these asteroids all depends on catching them way, way away from us. We need the time for our method to work. Then we have electric propulsion. It's an electric-powered rocket. Propulsion systems use electrical energy to change its velocity. Use electrical energy like batteries, electric current, and nuclear power for ignition and for the thrust required. Then we have a gravity tractor. And a gravity tractor, you take a body, park it near the object, and let their mutual gravitational attraction move it. You don't land on it. you stay away from it, and gradually, as you sort of lock in the gravitational lock, you sort of move away a little bit at a time. So you're actually tugging it away. So the spacecraft should be about 20 tons. It'll fly up to the asteroid, stop a short distance away, would hover there, firing its thruster to overcome the gravitational effect of the asteroid, and then it would use its own gravity to tug the asteroid off course. It would arrive at the Earth-bound asteroid about 20 years before it was due. At 20 years old, it takes a much smaller nudge to move it than if it's 4 or 5 years out. Then there's solar sails. This is a real interesting thing. The spacecraft propulsion system, they use the momentum of photons by the sun for propulsion. They utilize large, lightweight reflective materials to capture and reflect the solar radiation, thereby providing a continuous thrust. When light hits the sail, the photons bounce off, transferring the momentum and giving the sail a small push. And unlike traditional rockets, solar sails do not rely on chemical reactions. They work on the principle of radiation pressure. Now, sadly enough, these systems have yet to be developed. we know these will work, and we know we can develop them, and we do research on them to make, because one day we may need one. So, is the sky falling? Only Chicken Little knows for sure. Thank you very much.